welcome to the next session at J4K. My name is Viktor and I will be your demo partner here. And the topic will be Kubernetes and GitLab, specifically closing the loop. And I hope we'll get there. So let's get started. Not sharing, but presenting. So a few words about me. My name is Viktor. I'm from Hungary. It's 5 o'clock in the afternoon, and I will try not to be too short on sugar. This time, I work for GitLab as a product manager, and my team is responsible for GitLab's Kubernetes integration and infrastructure as code. And I'm super excited to show what we've got actually in this space for you. If you want to reach out to me, feel free to reach out to me on Twitter or by email. Both work, and I'm pretty active, especially on Twitter, less than emails. So, but what I want to speak to you about today, that we call the GitLab Kubernetes Agent, and mostly it will be a demo, so not just speaking, but to give you an idea what it is. There's docs behind the QR code. The basic idea is on the screen right now. The Kubernetes Agent has two components. It has what we call Agent K, the cluster side component, and the Kubernetes Agent server, the GitLab side component. And for a long time, GitLab had a certificate-based setup for the cluster that required your Kubernetes API to be available for GitLab. This was very understandable reasons, a no-go, especially for GitLab.com users. And the agent enables a secure connection even for GitLab.com users, because basically the cluster set component Agent K authenticates towards GitLab. So if your cluster can reach GitLab, then the connection can be set up. And from that time on, there's a bidirectional gPRC channel between your cluster and GitLab, which allows a huge array of new possibilities, actually. First of all, now we support pool-based deployments in the largely understood GitOps style, I would say. So you can get a manifest repository. I will show how it works, and GitLab will just pull from that into the cluster and apply the changes there. If you remove something, GitLab will prune up everything. But you can still use GitLab CI if you're familiar with that, and if everything you have is already set up there. With minor changes, you can start using this connection through GitLab CI as well and push changes down to GitLab. And we are working on more and more features that could even bring you your Kubernetes insights into the GitLab UI to have a truly integrated experience that GitLab's vision is for being a single application for the whole DevSecOps lifecycle. So this is what the agent enables us to do. And this is what we're going to speak about today. First, I won't speak about setting up a cluster. I will assume that you have that, but then we will start by setting up the agent in that cluster. And then we will set up pool-based deployments, push-based access, seeing how push-based works at the group level as well. And finally, we will use the agent to install what we call cluster applications. These are applications that integrate with GitLab, like Selenium, for example, for network monitoring and alerts, where you can configure the network policies within GitLab, apply them in the cluster, and if there's an alert, the alerts are surfaced to GitLab. I won't show you the whole setup here because we have only short time, but I'll show you how you can get started relatively easily with these cluster management applications that we provide. And if time permits, my plan was to add application metrics as well, but I failed setting up the DNS, so we won't do that. So prerequisites for this, there are quite a few. First of all, you need a Kubernetes cluster that you have local access, probably admin access, preferably. And you should start a new project. I recommend starting with the GitLab cluster management template. I will show you where it is if you don't know what this means. And finally, you will need a bunch of CLI tools. I will speak shortly where we use each of these if you're not familiar with them. .env basically sets up all kinds of environment variables for us whenever we enter a specific directory. I use that for Terraform, and there will be only once where we are going to use Terraform throughout this demo. And and you can skip that because that works really well from the UI as well. And I forgot to add Terraform to this list of CLI tools here. Then, of course, you need kubectl to do the first few initial applies. Then we have KPT. KPT is a tool to manage various Kubernetes packages that are stored in a Git repository. Actually, it grabs part of Git repository and can merge those changes. That's what we use it for, at least. And we use it together with Customize. So we get the installation for the agent using KPT. There's different methods as well documented if you just want to try out the agent. That we go with this one, Customize the customizer. And right now I need a GitLab Premium account for all of this, because today the agent is only available in Premium, but we are moving it to Core in the next few months, probably. Finally, I will use KineNS to see if something goes bad or if things work out as expected, and I will use the AWS CLI as my cluster will be an EKS cluster. The example project is in that place that I added here, but let's go to demo. So first of all, I told you that I will show you where you can find the project template. If you want to start a new project, then GitLab asks you if you would like to use blank or a template or something else. So we go with a template, and it's here, GitLab Cluster Management, use that template. That's what we are going to build on. So installing and setting up the agent. This project has a few branches with specific steps, and I will try to go with them most of the time, at least. So, but let's see. Okay, I just see that I shared only Firefox, so let's share the screen instead. So here we go, and now, okay, I have a beautiful README in this repository that I am going to run the demo against, so you can go through all of it. Actually, there shouldn't be any credential committed or not in an unencrypted way. So I already set up the cluster, and now we are going to register the agent. For that, I'm already in the repository, as you can see. So I just go into one of the Terraform projects that you can see here, and the .env already loaded all these nice environment variables that I will need here. Let's see how does it look like actually. So in my Terraform, it's super simple. This is the main thing. I just use the GitLab Terraform provider because I will need it for some details. And otherwise, I created a module that you feel free to use or check it out that will register the agent. You can run the same registration through the UI as well, if you prefer that, but let's try to be really GitOpsy here. So Kubernetes clusters, GitLab managed, integrate with the agent, and then you can select J4K demo. You can select this J4K demo because I already created a file under .gitlab agent J4K demo, and this will be my configuration for the agent actually. So what happens here is that we configure the agent through a file, and in my case, I will use Terraform to register this configuration as well, but you can use the UI as well to register the configuration. So let's see, Terraform apply. I will be a bit fast here, but I know that everything was already initialized. The plan showed what I expected it to show, so I will just run apply and auto approve it. And this shouldn't run long actually. So here we go. We have an agent registered. So the next task we have, let's see the README. Okay, we have it registered, but it doesn't mean much. It just means that on this page, if I reload, I now, actually I should see something, but I don't see, which is weird. Anyway, Next thing is that we have to grab the code that actually installs the agent. I'm going to switch to a different branch to make sure that I have just as much code as you would have at this point, which means that I don't have any agent specific code here. And I'm going to create a directory called packages, and I'm going to run this kpt command to get the code for the agent, and there was an error. Great. Why was, oh, there were too many arguments. Okay, there we go. This checks out the master of that branch and that repository, and I won't commit here anything because I just switched to master. But feel free to commit this. This doesn't contain anything that we don't need, and actually it will contain much less than what we will need in the end. But it shows you how to set up the agent in general, because here we will move into that directory, and it shows you it's actually a customized package. So come on, what's going on now? Okay, unable to find, oh, because I don't have to go in there if I add it here. So the customized configuration settings are the agent version. We will use version 13.3.3. This is the most recent one. The up to minor version, you should match your GitLab version. So if you are on 13.2, 14.2, then use version 14.2.x and so on. The CAS address will be gitlab.com in our case, and you can customize the name prefix, namespace, or you can disable, enable Prometheus scraping if you want to. So let's just run all those customizations, which for me means that I will just switch over to my master branch to make sure that everything is as I expect it to be. And now I should be able to extract the authentication token from the GitLab Agent Terraform project and put it into a file. Do not ever commit this file to Git, because this file is actually, oh, I made two things at the same, because this file contains a credential, but this is fine for us because okay, I will need to use a different cube context. Yes, and that's the right one. Perfect. So I will just apply the customized build that came from this package after running the these customized commands, and I can apply this into the cluster. Now I should be able to follow along here in Kinin S, where the namespace was created, and there's an error. I'm a bit worried that the error comes from Terraform, from the end of the Terraform run. As you could see here, this was actually the ID even this morning when I was going through all of it. So let's remove the agent and let's see what happens if we register it again. So I want to remove this agent, and it says I have no permissions to do so. Okay, then let's list all the agents that are available in my, yeah, we couldn't, there are no agents registered still. which is pretty weird because GitLab thinks that there are. I mean, Terraform thinks that there are. Let's run a destroy. All right, that will be the culprit. Later today, I forgot to clean up after I went through the demo, so I will have to do it now. What I'm going to do, I will go to our Terraform section and we'll just remove the state file because actually there is nothing in it that we would need now. Of course, you should not do such a thing in production. But now I can run Terraform again and it should work. I will just trust myself now. Again, and if we go back to Kubernetes clusters, now we have it registered. Perfect. So this shows that the agent did register. It shows where the configuration can be found, and there isn't much. It just shows a single access token that's available, but otherwise it says that it was never connected before. So let's change that never connected and connect to the agent. We go back here and we'll rerun these commands to get the token that actually already exists and it did not exist before. Okay, and I will have to change this again. And here we go. So now, as you can see, the only thing, the secret was created. Perfect, because that's the thing we missed until now. And if I start kind in S this time, there is a different error, but the interesting thing here is that we are good to go. This Kubernetes GitLab Agent YAML. Okay. So this comes from our configuration file that wants to pick up all the YAML files available for him. And we will change this actually simply. So let's speak a bit about this configuration file instead of rushing forward. As I said, you configure the agent in code. And in this code, you can specify where you can find your manifest files. We only support Kubernetes manifest, pure Kubernetes manifest. And right now, these manifests are in the node-GitLab/project name directory, and under that in this path. In this path, you can find the test, which actually just adds a config map. And this will be a hydrated version. I can remove it now because CI will add it back anyway. And there are the, now we have saved secrets here as well. So what happens next is that I will just remove this as well because we don't need it yet. And no, not this way. Let's do it in a different way. I will discard all the changes and we'll go back to another branch where everything is set up this way actually. And what I'm going to do now is I will just push out this branch to master. Or do I want to do that? Okay. So yeah, here the demo guts are not really with me because I did not prepare very well, as you can see. Anyway, let's do that. I guess force push is disabled in my project. Okay, so never mind. Let's try to follow in a more improvisative way then. So once we have the agent configured through customize and KPT packages, and we could apply the agent into our cluster, it should start synchronizing the cluster with our changes, with our repository. And what happens next is that with this manifest, okay. So now you can see that it started to apply a bunch of airbag errors and deployments are being, sealed secrets are being applied there. Yeah, we finally started to do some synchronization, which is pretty interesting here. I don't understand yet why it does all these things. Let's see if our default config map got to the cluster. Yes, so 31 seconds ago, this test manifest that just says it still works actually entered the cluster, which is cool. Okay, let's go back to our README and let's see where we are. So we added the agent to the cluster and see that pool-based deployments work right now. Now let's see if you can play a bit with the CI by adding this bit to our GitLab CI YAML. Actually, I have it already added. And the only thing I need to do now as a result is to go to my pipelines and see it here. So we are in GitLab CI now. There is the only setup here for the cluster is this Kubernetes agent, and still you can see the same agent using the kubectl getpods that we have in K&S. If I manage to increase the font size. Yes, here we go. So this is strange because this is different agent. Oh, because this one crashed loop back off, and here we go. No. Okay. So one thing you can see that this now we are in a crash loop back off cycle for some reason. And the reason is sealed secrets actually. For some reason it wants to use, oh, I know what's going on. Okay, the situation is that I had a more elaborate GitLab Kubernetes Agent YAML in this repo that I just removed a few minutes ago, and it cannot really get rid of the current one because it doesn't know what to do with all of those. So we will apply our changes again. And now hopefully it won't terminate continuously. Let's see a little bit. And if we rerun the pipelines here, then you should see the same pod names in the play CI job. I will get back to that in a moment, but in the meantime, let's see what we will miss during this demo because we are short running out of time. I will still try to do the group level setup, which means that you can access the same agent from a different project as well. Actually, you can specify either projects or groups. I will use groups here, and you can access this agent from different group and run any kubectl command or help command or any other command that accesses your cluster using your kube context from the other CI jobs from different groups and projects. Once we have that, you can actually turn the agent to manage itself as well. For that, why I have state secrets in this repository is because I prefer to use state secrets for secrets management, and you can install state secrets from its manifest. After that, you can grab the public key and commit it into the repository, and you can encrypt the token that we used before using state secrets using the public key, and store the encrypted key in the repository. And once we have all of these things done, you can set up the agent to actually use the state secret instead of a classical Kubernetes secret, and to manage itself from the Git repository that you have. So that's the basic idea, that you can go through that. And once you have all of these things, you can add to CI a few jobs that hydrate your KPT package with the customers command to a Kubernetes manifest and commit it into GitLab itself. And that enables you to have a fully self-contained management for the GitLab agent and for anything that requires pool-based deployment. And in the meantime, you can run pool-based deployment, as I will show you in a minute. So, okay, we still run this one, and hopefully we will get the pods soon. Our agent is still running. And finally, I will show you as well, as it runs, what would be the next item is how you can set up, for example, Prometheus using this cluster management project template that we started with. The template provides you a Helm file that shows you all the applications that come within the template. And under the applications, you can find Prometheus and the values YAML. And once you configure Prometheus, if you have anything to configure, like a host, for example, once you configure Prometheus here, you just enable it by uncommenting the line in the Helm files list here, and GitLab CI will apply the Prometheus Helm file resources to your cluster automatically. And that's how you can easily set up these applications within GitLab. Okay, it didn't work out this time, as you can see, and we are almost out of our time. So the best thing I can do is that I rerun this pipeline, or that we try to run the pipeline in another project where that I set up previously. As you can see, this is a really bare bones project. There is just a GitLab CI YAML. And what I would like it to run is just to get the kube context first. And after that, we'll get some namespaces as well. As you can see, there is no Kubernetes cluster attached, neither actually the certificate base, but we don't use that. So there is no attached cluster with an agent. So let's see what happens here if we run the pipeline now. And let's start this pipeline as well, why not? Okay, I see in the meantime that there are a few questions that came in. So no context, this is truly surprising to me. Let's see the questions. Does GitLab support any and all Kubernetes distribution application? And what about OpenShift? Yes, very good question, and thanks for asking. With the agent, we do support OpenShift. You have to tweak a little bit the installation. I mean, you can start with the KPT-based approach that I just presented, but after that, you will have to set up a few things. How does OpenShift cause them? not security groups, but something security group related notions that not every Kubernetes distribution supports. So you have to set up those. And once that's configured, you can install Agent K as I did. And it should work. And whatever you enable it to access, because you own the airbag rights around Agent K. As a result, you own what Agent K will be able to do in your cluster. So once you decide what it should access and what it should be able to do, the Agent K can do its job in an OpenShift cluster as well. So yes, as far as we know, we support all the Kubernetes clusters since we live within the cluster, and we try to be a good citizen there. So we use airbag extensively, and that's it basically. What are the with GitLab Kubernetes Agent compared to other market offerings for GitOps? I think the biggest two advantages are that it's integrated within GitLab. That's number one. And number two is that we are, what do I wanted to say? Sorry, I'm getting tired. So we only support Kubernetes manifests for deployment. As a result, this is way more limited than other tools like Argo CD or Flux. At the same time, we are integrated with GitLab, which means that we will get even the observability part within GitLab very soon, even if not today. Moreover, it's very easy to set up for developers. As you can see, they can still use even CI if they don't want to go to pool-based model, and they don't have to change their workflows. So you have a platform engineer or an SRE who sets up the agent, and once they enable the group level access, as I showed you here, it's seriously just a single line that you have to configure. Where do I have it? Here, once you enable the group level access, any developer in your company can start using that agent. And the second reason is that we are currently adding more and more features to the agent. We're actually building out all the Kubernetes integrations around the agent. As a result, we are looking actively into how to provide some observability of your cluster within GitLab using the agent connection that's already set up. And again, all of this is secure because you own the airbag rights around the agent. So we will be only able to access, or finally the users will be only able to access the features that you enable them to access. A feature that will come out likely this month or the next is actually through the CI/CD tunnel. We want to do something like job impersonation or user impersonation, which will mean that you can specify airbag rules around the specific job. And you can say that that job can deploy, but the other jobs cannot deploy, or depending on the agent in one cluster, you enable deployments for the job in another cluster you don't, or you can do the same with the users as well. Whoever started the given pipeline, they can do the deployment, or the deployment will fail because they don't have the rights for that. So I would say these are the primary two reasons why I think the agent is a better option. And even though I said we don't support anything but pure manifests, as I showed you here, it's relatively easy to set up GitLab CI to hydrate a package, for example, using customize into pure manifests. And you can, if you don't use Helm hooks, you can even use the Helm template command or any other option, and commit from within CI back to your repository. And then you can even review the manifest changes in your merge request if you want to. That are actually the changes that will be applied to your cluster anyway. Or if you don't want, you can set up a CI script for that and just merge the changes to your project. So we think that there are some limitations, of course, especially today, as it's relatively new. It was released last September, the first version of the agent. But if you want a GitLab integrated experience with the with Kubernetes, then I think the agent is a much stronger offering than, and especially longer term, if you want to invest in something, than the other tools can provide, simply because they